Welcome everybody to our presentation. This is Business Math. We are discussing the derivative of a logarithmic function. This is Magda Talib Al-Hinai from Sultan Qaboos University, and I welcome you all. We start our presentation with the procedure of implicit differentiation. We have y a function of x, an implicit function of x, and it is differentiable with respect to x. Also, we want to find the derivative of y with respect to x. We want to find dy by dx. This can be done through the following steps. As long as we cannot split y on one side and solve for y and get everything which is not containing y on the other side, so we go ahead and just differentiate both sides of the given equation with respect to x, and then in the second step we solve for dy by dx. Now let's explain this with an example. Given y cubed plus 2y minus x squared equals 8, we're asked to find dy by dx. Okay, we all see that we cannot have y on one side and everything else on the other side. We cannot solve for y. So we will just go ahead and differentiate both sides of this equation, and we call it equation 1. So differentiate both sides of equation 1 with respect to x. What's the derivative of y cubed? It is 3y squared dy by dx. What's the derivative of 2y? It is 2 dy by dx. What's the derivative of minus x squared? It is minus 2x. And of course, the derivative of 8 is 0. So by differentiating both sides with respect to x, we get 3y squared dy by dx plus 2 dy by dx minus 2x equals to 0. Can we see that we have dy by dx common in both the first and the second terms? Yes. Okay, so we take it as a common factor. So we have 3y squared plus 2 multiplied by dy by dx minus 2x equals to 0. Next, can we move 2x to the other side? Yes, and change its sign. So we have 3y squared plus 2 into dy by dx is equal to plus 2x. Next, can we divide both sides by this factor? Yes, it's never 0. So we get dy by dx is equal to 2x over 3y squared plus 2. And that's the end for this example. There we go to another example where we need to find the slope of the line tangent to the curve, and we have the curve as an implicit equation, x cubed minus y minus x squared all squared equals 4 at the point, and we have the coordinates of the point 1 and 2. Okay, we call this equation 1 because we start our solution differentiating both sides of 1 with respect to x. So let's see, what's the derivative of x cubed? Yes, 3x squared. And what's the derivative of this bracket power 2, this square bracket? Of course, we use the chain rule. So we put the 2 down, multiplied by the bracket, multiplied by the derivative inside. We put the 2 down, and then we multiplied by the bracket power 2 minus 1, which is power 1. And then multiply by the derivative of inside. Okay, now let's see what we will do. Here's the 3x squared, and then here is the minus 2. Yes, here's the bracket power 1. Here is the derivative of inside. The derivative of inside is dy by dx for y. And the second term is minus x squared. It is differentiated to be minus 2x. Yes. This is equal to the derivative of 4, which is constant, which is equal to 0. Now we need to find the slope. We can solve for dy by dx and bring the expression for dy by dx, but I don't think we need to do this as we've done like in the previous example, because in the previous example we were asked to find a formula for dy by dx. But in this example we need to find the slope, the value of dy by dx when x equals 1 and y equals to 2. So we can simply just plug in every x, 1 for every x and a 2 for every y, and then we find the dy by dx immediately. So here we put 3 into 1 all squared. This is for the value of x, minus 2, open bracket. For y we put 2, minus 1 squared for x squared. And then here is the dy by dx in the case when we have x equals 1 and y equals 2, minus 2 times 1, which is 2x. This is equal to 0. Simplification, we get the value of dy by dx to be the slope to be equal to 7 over 2. Next, we know the equation of a straight line when we have a slope and a point, and here is the point. This is the x1 and the y1, 1 and 2. We plug in the 1 for the x and the 2 for the y and the 7 over 2 for the slope, so we get the following equation. Cross multiplication, we have 7 into x minus 1 equal to 2 into y minus 2, and then simplification, we reach the equation of the line tangent to the given curve. Okay, everybody, let's see the following application where we are given the demand equation to be P equals 100 minus Q squared. This is quite simple, and we're asked to find the rate of change of the quantity Q with respect to the price P. We call this equation 1 so that we differentiate both sides with respect to P because we are asked to find the rate of change of quantity with respect to price. So we start our solution differentiating both sides of equation 1 with respect to P. The left-hand side, the derivative of P with respect to P is 1, and the right-hand side, the derivative of 100 is 0, while the derivative of minus Q squared with respect to P will be minus 2Q dQ by dP. Simple enough, we say dQ by dP is equal to minus 1 over 2Q. Next, we move to the following example. The savings of a country S. The savings S of a country is related to the national income I through the equation S squared plus 1 over 4 I squared is equal to SI plus I. And we call this equation 2. S and I are in billions of dollars, and we're asked to find the marginal propensity to consume. We are given the relation between the savings and the income of the country, so we need to find the derivative of the savings with respect to I, which is the marginal propensity to save. And then we know how whenever we have the marginal propensity to save, we can find the marginal propensity to consume through the relation that the sum of the marginal propensity to consume and the marginal propensity to save is 1. So now let's go ahead and start differentiating both sides of this implicit equation with respect to I. So here we have the derivative of S squared will be 2S ds by di, while the derivative of 1 over 4 to I squared will be 1 over 4 multiplied by 2I, which is half I. This is equal to the derivative of the right-hand side with respect to I. The second term is simple enough. We differentiate I with respect to I, we get 1, but here we have the product rule. So we need a product of two functions, and we need to apply the product rule. So this is equal to, when we apply the product rule, we have I multiplied by the derivative of S with respect to I plus S multiplied by the derivative of I with respect to I, which is 1, plus the derivative of the second term, as I said, it is 1. Now, we are given that I equals 16 and S equals 12. We plug in for I 16 and for S 12 whenever we find I and S. So we get 2 times 12 ds by di plus half 16 is equal to 16 ds by di plus 12 plus 1. So simplification gives us ds by di is equal to 5 over 8. As I said, this is the marginal propensity to save. So in the second step, in the coming step, we find the marginal propensity to consume to be 1 minus 5 over 8, which is 3 over 8.